Today we're going through the Year 8 Mathematics booklet, which is Venn diagrams and two-way tables. We'll start with a revision quiz first. Question number 1 says 2 6-sided dice are thrown. Draw a table showing all the possible outcomes of these rolls. I'm going to start with my first die being thrown. 1, 2, 3, 4, 5, 6. 6 sides. And then I'm going to start with my second dice. 1, 2, 3, 4, 5, 6. Now that that's all labelled, I'm going to fill up my table so it has all of the outcomes. So 1 and then a 1. I can roll 2 and then a 1, 3 and then a 1, 4 and then a 1, 5 and then a 1, or 6 and then a 1. I could do 1 and then a 2, 1 and then a 3, 1 and then a 4, 1 and then a 5, or 1 and then a 6. I can do 2 and then a 2, 2 and then a 3, 2 and then a 4, 2 and then a 5, 2 and then a 6. 3 and then a 2, 3 and then a 3, 3 and then a 4, 3 and then a 5, 3 and then a 6. Or I can do 4 and then a 2, 4 and then a 3, 4 and then a 4, 4 and then a 5, 4 and then a 6. I can do 5 and 2, 5 and 3, 5 and 4, 5 and 5, 5 and 6. And my last one is going to be 6 and 2, 6 and 3, 6 and 4, 6 and 5, or 6 and then a 6. Now part B says, hence or otherwise, what is the probability of? Now I can see through my table that I have 36 total outcomes. So the probability of rolling 2 5s is only going to be 1 out of my 36 outcomes. Rolling a 5 and then a 2. Now rolling a 5 and then a 2 is again only one of my outcomes out of my 36. Only rolling 1 6. Now if I look up here, rolling 1 6 is these values over here and also these outcomes over here. 5 plus 5 is 10. So that's 10 out of my 36 outcomes, which can simplify down to 5 over 18 as my probability. Now rolling at least 1 3 means all of my 3s. So these values over here, these two, and also these two. That would be 11 out of my 36 outcomes. Rolling numbers with a sum of 12. Now with a sum of 12 is only 1, which is 6 and a 6. So that is 1 out of my 36 outcomes. Rolling at least 1 prime means I'm going to go 2, 3, and 5. And then also these values over here. So we can also go horizontal, 1, 2, and then also for the 5s. That gives me 27 total outcomes out of my 36. 27 out of 36, which simplifies down to 3 over 4. So I can either roll a 2, a 3, or a 5. Rolling numbers with a sum of 7. So if I go up here, a sum of 7 will be anything in this diagonal over here. That gives me 6 total values. So 6 values out of my total 36 outcomes, which is 1 over 6. Rolling 2 even numbers. If I look up here, rolling 2 even numbers would be a 2 and a 2, 2 and a 4, 6 and a 2. I could also go 4 and 2, 4 and 4, 6 and 4. 2 and 6, 4 and 6, 6 and 6. That gives me 9 total values out of my 36, which simplifies down to 1 over 4. Gary has 50 games on his computer, 20 of which are action games, and Gary randomly picks 2 games to play. What is the chance of Gary picking 2 action games? Now, 20 out of the 50 games are action games. So it's going to be 20 out of 50 multiplied by, there's one less game now, 19 out of 49, which gives me a total probability of 380 over 2,450, which we can simplify down to 38 over 245. Now, no action games. If 20 of my games are action games, that means 30 out of my 50 games are not action games, and after I've picked one, I'm left with 29 over 49. Into our calculator to get our final fraction, 2450 And we can simplify that down as well. At least one action game. So at least one means we do 1 minus the probability of no action games, which we know is 87 over 245. This will give me 158 over 245. Now last part for this one says exactly one action game. Exactly one action game means if I pick an action game first, so 20 out of 50, I don't want an action game, so 30 out of my 49 remaining games. Or my second case is that I don't pick an action game at first, so 30 out of 50, times by I pick an action game the second time out of my 49 games. If I add that together and simplify my fraction, I get 24 over 49. 2 cards are drawn from a standard deck of cards without replacement. What is the chance of drawing 2 hearts? Now 2 hearts, if there are 13 out of 52 hearts, this is without replacement. Times by, I have 51 cards left and only 12 are remaining hearts. So I'm left with 12 out of 204, which gives me 1 over 17. Now no spades. My 52 cards, I want any of the other 3 suits. Times by, once I've picked out 1 card, I've 1 less in each, which gives me 19 over 34. A diamond and a club in any order. Now a diamond and a club, there are 13 out of 52 times by 13 out of 51 remaining cards. Because these can be in any order, I'm going to multiply it by 2 because my chance doubles. That gives me 13 over 102. A heart and then a diamond. Now a heart would be 13 over 52 again, times by 13 for the other suit out of my 51 remaining cards. Because this says and then, we don't multiply it by 2 because order does matter. So this gives me 13 out of 204. At least 1 ace. I'm going to find the probability of no aces first, and then we can do 1 minus our probability. So 48 out of 52 because there are 4 aces in a deck of cards. Times by 47, 1 less card after we've picked one. That gives me 188 over 221. Now, at least 1 means we're going to do 1 minus getting no aces. And that gives me 33 over 221. Now 2 court cards. There are 12 court cards out of my 52. Once I've picked one, I have 11 left in my remaining 51 cards, which gives me 11 out of 221. Question 4 says, if a bus is not late, there is a 30% chance that Lucy will stop to buy a snack after school. She never buys a snack if the bus is late. On any school day, the chance that the bus is late is 20%, and on days when Lucy buys a snack, there's a 40% chance that she will eat it in the park. She only eats a snack in the park if she bought one after school. So what is the chance on a school day that Lucy eats a snack in the park? First, let's find the probability that the bus is not late. The probability that it is late is 20%, which means 1 minus 20%, which is 80%, gives me the probability that it's not late. Now, if it's not late, we're going to see what's the chance that she buys a snack. So this, not late, and now she's buying a snack, is equal to 30%. Now after that, there's a 40% chance that she has it in the park. So in park is equal to 40%. So to find out the total chance that on a school day she eats a snack in the park, we're going to multiply all of our probabilities because they all have to happen at once. So we do 80% times by 30% times by 40%. This gives me 9.6%. So the chance that on a school day her bus is not late, she gets a snack, and then she eats it in the park is 9.6%. Moving on to standard exercise 4.1, foundation says 40 people are enrolled in either Class A or Class B. How many people are in Class B? If the number of people in Class A is, if it's 11, we would do 40 minus 11, which would give me class A, and that is 29. Same thing here, 40 minus 4 is 36, 40 minus 25 is 15, and 40 minus 34 is 6. 65 people are to decide whether to join basketball or baseball. Each person is required to join one team and one team only, so they can't join both. How many people are in the other team? After everyone chooses, there are 15 people in the baseball team. So 65 minus 15 gives me 50. 32 people are in the basketball team. 65 minus 32 gives me 33. Now moving on to standard exercise. In a small university teaching 500 students, it is required of every student, in addition to their usual studies, to learn one of the two subjects, software engineering and Latin. Students can choose to study both subjects, and it's known that 278 students study software engineering, while 330 students study Latin. How many students are studying both subjects? Now, how many people have chosen software engineering? It's 278. Plus 330 students have chosen Latin. Now, if I minus the amount of students there are in total, because this number over here is greater than 500. If it's greater than 500, whatever the extra numbers are, is the amount of people that do both. I'm going to add these together and then minus the total amount of students. That will give me the overlap. The overlap is how many students do both subjects. So this gives me 108 students. Now my reasoning is going to be that since every student takes at least one subject, we subtract the total from the sum of software and Latin. So we subtract the total amount of students from the sum of software and Latin to remove the double counting. Hence, calculate the number of students studying only software engineering and the number of students studying only Latin. So, only software. If my total is 278, I'm going to minus the overlap, which is 170. And we're going to do the same thing here. Only Latin, I'm going to get my total amount minus the overlap, which gives me my total only Latin. Now we're going to draw a Venn diagram to showcase what we have just learnt. So 2 circles for my Venn diagram. This is going to be software. This is going to be both, and this is going to be Latin. Now only Latin was 222, only software was 170, and my overlap was 108. Now, a hobby store only sells yo-yos or model planes. A hobby store salesman made sales to 23 different people at work in one day. He sold 15 model planes and 22 yo-yos. There are also 10 customers that only browse in-store that same day. We're going to construct a two-way table representing the above information. Now, for a two-way table, they sell yo-yos. So yo-yos, either I get a yo-yo or I don't get a yo-yo. Either I get a plane or I don't. 10 people only browsed, which means that they did not get any yo-yos or any planes. There were 15 model planes sold and 22 yo-yos. So 22 yo-yos is my total. And my total planes are 15. Now to find the people that got both, we're going to find the overlap again by doing 15 plus 22 minus 23. That gives me 14. So there are 14 people that got both a yo-yo and a plane. That means that I can use subtraction. 22 minus 14 gives me 8. That's how many people bought a yo-yo but no plane. And how many people got a plane and no yo-yos is going to be, here is 1, this would be 11. Now this is 18, and I can fill it up by saying that this is 33. That's my two-way table drawn. Now we're going to construct a Venn diagram representing our information. So again, I'm going to draw 2 circles, just yo-yos, and just a plane. So we're going to write yo-yo, plain, both. I know that there were only 10 people that just browsed, so I can write 10 outside. 1 wanted a plain, 8 people got a yo-yo, and 14 people, you can see over here, got both. So this becomes my Venn diagram. Now, hence or otherwise, if a hobby store customer from that day was randomly chosen, what's the probability that they bought a yo-yo? Now, total yo-yos over here was 22. So the probability that they got a yo-yo was 22 over my total, which was 33. If we scroll up here, we can see 33. Bought a model plane, we can see the total for just plane is 15. So we're going to write 15 over 33. Only bought one type of item. One type of item is 8 plus 1, so 9 out of 33. And bought both types of items, so that is both 14 out of 33. Did not buy anything, that was 10 customers out of my 33. And bought nothing or a yo-yo. Remember, or means that we add. So bought nothing was 10 out of 33. Or bought a yo-yo, so bought a yo-yo was 22 out of 33. So I'm going to write plus 22 out of 33. That gives me 32 out of 33. I'm going to translate the following into words. Now remember, when it's facing down, it's and. So this is A and B. If it's up, it's A or B. This is saying A and B or C. This is saying A or B, that probability, and C. This would be X and then in brackets, Y or Z. And this would be J or, brackets, O or P. Now moving on to standard exercise, this is saying A or the complement of B. So if I say that this is my A, this is my B, A or the complement of B. So anything aside from A or B and including A. Because we either want all of A or anything but B. So I'm just going to label that all of A and anything that is not B. For this one, this is saying A and the complement of B would just be this section over here. Now over here, we have A and the complement of B all complemented. So if this is my A and this is my B, I know this is A and the complement of B, so it's going to be anything but this section shaded. So this section shaded is just this. Now this one says A and B, which we know is this, but we want to get the complement of it. If we want to get the complement, we're just going to do, let me label it first, anything but the fact where they overlap. So this is everything but when they overlap, which is this section over here. Question 2 says a researcher takes a survey of 100 students to see what sports they play. 64 of the students play basketball and 52 of the students play cricket and 20 play neither sport. So let's draw a Venn diagram over here. If I know that 20 play neither sport, I can write 20 over here. Now this is basketball, this is cricket. So 64 play basketball and 52 play cricket. I'm going to minus 80 because there's 100 students in total, but we know that 20 do not play either. So 80 students play sport. That gives me 36. So that means that the students that play both is 36, which leaves me with 28 for basketball and 16 for cricket. Now we're going to find the probability of B or C. Now B or C means either basketball or cricket, so that's 80 students out of my 100. This one says B and C, so that would be where they overlap. 36 out of 100 students gives me 9 over 25. The next one says the complement of B. So 100 minus who does not play basketball. That would give me 64. So minus 64 leaves me with 36 students. So the probability is 36 out of my 100 students, which is 9/25. Now this is everyone but who plays cricket. So again, I'm going to do 100 minus my 52 students that play cricket, gives me 48. So my probability is 48/100, which is equal to 12/25. Now moving on to challenge questions. Number 1, a survey records whether neighbourhood residents play golf, tennis or badminton. 16 residents play golf, 15 residents play tennis, 13 play golf and tennis, and 1 resident plays golf and badminton, and no residents play all 3 sports. Additionally, no resident played only tennis. So out of the 40 residents, 8 did not play any sport. Now we can actually construct a Venn diagram with this information. I'm going to start by drawing 3 circles for my 3 sports. So that's 1, 2, and we can do 3 over here. Now from the last part, we know that 8 did not play any sport. So I can write 8 on the outside and we're not going to include that there. Now we know that no residents play all 3 sports, and we also know that no resident played only tennis. So I can say this is tennis, I can say this is golf, this is badminton. Now no one played just tennis, and I know that 16 play golf, 15 play tennis, and 13 play golf and tennis. So golf and tennis is this overlap over here. So we can write 13 over here. Now 1 resident plays golf and badminton, so golf and badminton is this overlap over here. Now since this whole golf section is filled up and 16 play golf, 16 minus 13 minus 1 gives me 2. And same thing over here, I know that 15 residents play tennis, and I've already accounted for these 3, which means this gap over here would be 2, so that this total tennis area adds up to 15. Now that I've done all of that as well, I'm left with 1 more. I have 3 already accounted for, and I have 40 people interviewed. So out of the 40, I can minus the 8 people who don't play, and then I can minus 2, 2, 1, and 13. So that adds up to 18, so I could do minus 18, and that will give me 14 in total. So that means that the people who only play badminton is 14. Now if I move on to part B, we're going to see what the probability is if we pick someone from random and they only play badminton. If we scroll up here, only playing badminton was 14. So 14 out of 40 residents, 14 out of 40 residents play badminton. So 7 out of 20. Only play golf, again, if we scroll up here, only playing golf was 2. So I can write 2 out of 40, which gives me 1 out of 20. Now plays golf, but not badminton. If we go up here, plays golf, but not badminton, means we only want this section over here, which is 15 out of 40. So 15 out of 40, we can simplify down to 3 over 8. Plays golf or badminton only. So golf only, badminton only would be 16 out of 40. So down here, we can write 16 out of 40, which simplifies down to 4 over 10, so 2 over 5. Does not play any sport, or plays badminton and plays golf. So does not play any sport was 8, or plays badminton and plays golf. Plays badminton and plays golf was an extra 1. So this would mean 8 over 40 plus 1 over 40, which gives me 9 over 40 as my final probability. Show the regions represented by the following on a Venn diagram. So this is A, or B, and C. So what we're going to do here is draw 3 different circles for A, B, and C. A, or, means all of A, or B and C. B and C overlap over here as well. For part B, we want A or B or C. So that would be A or B or any part of C. For this one over here, we have B and A or C. So A or C means any part of this, but B and means it only has to overlap with B. So we would only shade in this region over here. Now this one says A and B and C means the only time they overlap, which is this middle section over here. Now we can move on to homework. Now, the following two-way table shows whether a group of 80 people like ducks, geese, or both. Show the above data in a Venn diagram. So, ducks, geese, or both. So I'm going to draw two circles. One for ducks, one for geese, one for both, and then we'll write our none, which hates ducks, hates geese, which is 11, over here. Now those who like both is 22, those who just like geese is 14, and those who just like ducks is 33. So we can fill in our information here, 33, 22, and 14. Hence or otherwise, if a random person is chosen, what's the probability that they like geese? Like geese is this section over here, which is 36. 36 out of my total 80 people asked. Likes ducks but not geese. Likes ducks but not geese is 33. So 33 out of 80 people asked. Likes both ducks and geese was 22 out of 80. And likes geese but not ducks is 14 out of 80, which gives me 7 out of 40. And we can simplify this one as well. A group of students is given the choice to join at least one of three clubs: chess club, drama club, and art club. It is known that 15 students join drama club, 6 students join both drama and chess club, and 4 students join both drama and art club, and 2 students join all 3 clubs. 24 students did not join any club, and we're going to draw a Venn diagram. So I'm just going to have my 3 circles over here. And inside, I'm going to write chess, drama, and art. Now we know that 2 students join all clubs and 24 do not join any. If 4 students joined both drama and art, then there are going to be 2 over here. Since 6 students joined both drama and chess, and I've already accounted for 2, I have 4 left up here. And I've filled in almost everything. So if I know 15 joined drama, 15 minus 4 minus 2 minus 2 gives me a total of 7. Now these 3 I cannot figure out because we need more information. How many students join only drama and art club? So I'm going to look here, it's only 2 students. How many students join only chess and drama? Only chess and drama becomes 4 students. And how many students join drama club only? We figured out was 7. Question 3 says 245 students are enrolling or considering enrolling in biology or physics tutoring at a tutoring center. 157 students are taking biology, while 133 of the students are taking physics. 44 of the students are still deciding whether they want to enroll. Construct a two-way table and a Venn diagram displaying the above information. For my Venn diagram, I'm going to draw 2 circles. Be physics, this can be both, and this can be bio. So, 44 students are still deciding to enroll. I'm going to write 44 outside. To find the overlap, I'm going to do 157 plus 133 minus, we're going to do 245 minus 44. That would give me the overlap, which is 89. If 89 do both, I have 68 left for bio and 44 left for physics. Now we can construct a two-way table. So let's do bio and then not bio and then total over here. Drawing up my table and then also adding physics going down, so 44. And I know that only physics is also 44. That gives me 88 total. Now bio and phys doing both is 89, which left me with 68 for just bio, which is 157 for just bio. Now my total for physics was 133, 112 for total not doing physics, and that gives me a total of 245 students in total, which matches up to the question. Now, of the students enrolled in physics, so enrolled in physics was 133, what fraction are also enrolled in bio? So that would be 89. Now, what is the probability that a student has enrolled in neither course given that they do not take biology? Out of the students that do not take bio, which is 88, the amount that have not enrolled in either course is 44. So we would write 44 over 88. 44 over 88, which gives me a total probability of a half. Question 4 says, in a class of 30 students, 20 like English, 16 like maths, and 4 students like neither subject. So if we're going to draw our Venn diagram with the 2 different options, we have math, both, English, and we know that 4 like neither. Now to find the overlap of who likes both math and English, we're going to do 20 who like English plus 16 that like math minus the total. Now the total will be 30 minus the 4 students that don't like either, so that's going to be 26. Now that gives me 10 students that like both math and English, which leaves me with 6 who like math and 10 who like English. Now part B says, what's the probability that the student likes only math? Only liking math was 6 out of my total 30 students, which simplifies down to 1 over 5. Now likes both maths and English was 10 out of 30, which gives me a third. Now likes English, but the complement of likes English, so does not like English. We can do 1 minus likes English, which was 20 out of 30, which is equal to 10 out of 30, which is also 1/3. Likes either math or English. Maths or English means anything in this section over here, which was 26 out of 30. So 26 out of 30 simplifies down to 13 out of 15. In a group of 70 students, 30 students study geography, 46 study history, and 20 study both. Draw a two-way table to represent the above information. We have geography, not geography, and our total. Drawing up our lines so we can create a table. And then also across, because we're going to add who likes history, who does not like history, and then our total for that as well. Ones that liked both geography and history was 20. Now there were 30 that liked geography and 46 that liked history. That leaves me with 26 over here, 10 over here. I can also fill in the rest of my table. This would be 40, then this would be 14, and this is 24. Now we're going to draw a Venn diagram to represent the information as well. So I'm going to draw my 2 circles for geography and then also for history. I know that 20 liked both, which left me with 10, 26, and then 14 that liked neither. Now, hence or otherwise, find the probability that a student studies history and geography. History and geography was this overlap over here, which was 20 over 70 students, which is equal to 2 over 7. Now, neither subject was 14 out of 70, which is 1 over 5. Geography only, we can see here, was 10 students. So 10 out of 70 gives me 1 over 7. History, but not geography, was 26 out of my 70 students, which gave me 13 over 25. Geography or history was anyone in this section. That gave me 56 out of 70. And geography, but not history, if we scroll up here, geography, but not history, was 10. So 10 out of 70 was my final probability. And that's the end of today's booklet.